Kharash effect or peroxide effect. It is a reaction which is given by hydrogen bromide in the presence of a peroxide. It is a free radical addition reaction and it is anti-Markovnikov addition. Markovnikov addition we have already studied and it is anti-Markovnikov. So that means that negative part of the adding molecule, say HBr we have, so Br minus and H plus is the species we get, and Br minus attaches to that double bonded carbon which has more hydrogen atoms. Whereas in Markovnikov, Br minus will attach to that double bonded carbon which has less hydrogen atoms. So in this condition, the difference is because of peroxide. If peroxide is present, then you will have anti-Markovnikov addition. If peroxide is not present, you will have Markovnikov. Let us take propene, and if you have HBr and peroxide is absent, then Markovnikov addition occurs and you get the product as CH3, CHBr and CS3. And if you have peroxide along with HBr, so what will be the product? You will get CH3, CH2, CH2Br. So in the presence of peroxide, Br negative will attach to carbon having two hydrogen atoms, that is CH2 carbon, and whereas when peroxide is not present, you will get the product where Br minus is getting attached to the middle carbon. So in the above product you can see that Markovnikov addition is happening, Markovnikov addition, and in the below product anti-Markovnikov addition is happening, anti-Markovnikov addition. So peroxides make this possible and only HBr gives Kharash effect or anti-Markovnikov addition. HCl will not show anti-Markovnikov addition because in HCl the bond cleavage is an endothermic process, whereas HI does not give Kharash effect because in HI I free radical is not stable, which is required for this reaction. I free radical combines with another I free radical and it forms I2. So HI will not give this reaction, HCl will not give this reaction, and only HBr gives anti-Markovnikov addition in the presence of peroxide. Now let us see what mechanism is followed. So the mechanism is given over here. So the first step is formation of free radical. So here we have benzoyl peroxide we have taken, this benzoyl peroxide. So benzoyl peroxide is broken down like this: benzoyl peroxide C6H5 CuO OCO C6H5. This is benzoyl peroxide, and how bond cleavage occurs is middle bond breaks like this and this, and it gives two free radicals. We will get two free radicals like this C6H5 CO and O free radicals. Such free radicals will be produced two in number. Now in initiation step, what happens is step 1 is initiation. Step 1 is initiation, and in initiation what happens is you will have this this free radical getting reacted with HBr. So what happens is O free radical will abstract H free radical from here. So this will break down like this. H free radical will attach to O free radical and you will get C6H5 COOH and free radical, Br free radical. This Br free radical attaches to, I'll show you in further slide, this Br free radical in propagation step. Step 2 is propagation, where Br free radical reacts with propene. So the objective here is to produce Br free radical will attach to double bonded any of these carbon in such a way that the free radical generated after that should be more stable. So see, Br free radical will attach to this one. So you will get this CH3, CH free radical, CH2, Br. Because 2-degree free radical is more stable. So Br is getting attached to the last carbon and free radical is generated on the middle carbon. Now H free radical will combine over here and you will get CH3, CH2, CH2Br. So this is happening in propagation step. And the last step is termination, where all free radicals combine with each other to give neutral species which are more stable. So this was what Karash effect is. Next is nucleophilic addition reaction. Such kind of reactions happen in carbonyl compounds, in aldehydes and ketones. For example, if we have a carbonyl carbon like this and you have a nucleophile, if you have a nucleophile, let me show you this. If we have a nucleophile, something like this, Cn minus, now this bond will break down like this, minus and plus, and this Cn minus will attack this, so it will become O minus and Cn. Further, if you do hydrolysis for this, so after hydrolysis what will happen is this O minus gains H plus, so you will get a product like this. So what is happening in the first step? This is a nucleophile. This is a nucleophile. So first step is attack of nucleophile. Because of that, the name goes like nucleophilic addition, because nucleophile Cn minus is getting attached to carbonyl carbon. So first step is attack of nucleophile, and nucleophile is getting attached to a double bonded carbon. So this is known as addition. So overall the reaction is nucleophilic addition. That's it.